Uh, Good morning, everyone. So today we'll start with Hadoop development session one. Okay. So let us see what is Hadoop development and what and all Hadoop development components will comes under development part. Okay. So let us see. So development part where we have Hadoop distributed file system, which comes under what and all topics we can see. Let us see here. So let us wait. Let me open. On part of development course, so we are going to cover the introduction of big data, introduction to Hadoop, starting Hadoop, then MapReduce version 1, MapReduce version 2, Yarn, and Hive, Pig, Scoop, HBase, Woozy, and also Hadoop 1x installation. We are going to cover it here. Okay, so let me start with the first one. So big data introduction is not required. So we'll directly go with Hadoop introduction. Okay, so HDFS. HDFS is like Hadoop distributed file system. So how the file system is storing in Hadoop, and also Hadoop is a components of two components Hadoop is having. One is HDFS and another one is HDFS is having two components, like Hadoop is having two components, HDFS, and another one is MapReduce. So HDFS is storage layer, what I can say, and MapReduce is processing layer. Okay, so storage layer. For example, if you have copy a file from outside to Hadoop, so the file will be split into blocks. You can see it here, the HDFS file system. It is created a directory. Under the directories, the files will be storing. So this is Hadoop file system storage level steps. Okay, so let me take it. Let me take a paint. Okay, so this is your Hadoop environment, Hadoop or HDFS, anything we will call it as. Okay, for example, if we have a file is available, you have a file called 100 GB, 100 GB file is there. Okay, so suppose if you are copying this file into Hadoop, so when you are copy this file into Hadoop, okay, so generally other than the Hadoop, so how it will be? Okay, so Hadoop is a framework which is consist of storage layer and processing layer. So we can see how it will be storing and how it will be processing. If you see here, if you have a 100 GB file, so if you want to transfer the 100 GB file from outside any of the file, so any of the file from outside to Hadoop, so when you transfer, it is not storing as it is. Generally, if you take it other than Hadoop, so this is your file, and if you copy your file from outside to, for example, this is Oracle. Okay, so if you copy it, this is storing as it is, right? So for example, if you have a 100 GB file, and it will, when you copy it, it will store it as it is 100 GB file. But that is not the case in Hadoop. Okay, so Hadoop is having a cluster. A cluster is like data nodes, name node. Okay, so let us see how Hadoop cluster is there. So one name node, so multiple data nodes. More than one node is called, I can say it as a cluster connected with in a network called cluster. You see, so the box, upper box is, I can say, name node or master node, name node, name node, and the below boxes data nodes. Okay, so these data nodes. I can call it as a DN, data node, DN3, DN4, DN5. Okay, so these are data nodes, and this is name node, and these are the data nodes. So this is Hadoop architecture. Hadoop is This is Hadoop architecture storage layer. So it comes under to storing the data. So where here the data is storing. Okay. Then when it comes to the how it is storing the data. So let us see. So when you copy a file, when you copy a 100 GB file, how it will be storing into Hadoop? It is not storing as it is the file. Okay. The file is, before saving, the file will be split into pieces, like like pieces. The file will be split into pieces like this. The pieces, we'll call it as blocks. You see, the file will be split into blocks like this, and each block has been replication. Each block will be copied into the available data nodes in a cluster, Hadoop cluster, into three copies each block. For example, okay. So for example, if you take it block 1, B1, block 1, and again another node, second copy, block 1, and any other different node, block 1, block 2, block 2, block 3, block 2, block 3, block 3. Something like it will create into, for example, if you take it a block 1. So let me take a block 1 green color. So this green color is, you see, this green color block 1. So where is the block 1? You see, block 1. And if you take it block 2, orange color. So block 2, not this one. So different. For example, I can say it here. Block 2. Okay, this is not the block 2, wrong. So block 2. Different data nodes, it is storing the copies, each copy. And if I can go with block 3, for example. So block 3, one copy, block 3, block 3. How it is creating? Similar different data nodes. The file will be split into blocks, right? And each block is replicated three separate data nodes. Okay, then let us see. This is block 4. Okay, so like this way, this will create. So this is Hadoop distributed file system. The when you copy a file, so file is split into blocks, small pieces called blocks, and each block is replicated by default 3 copies into Hadoop distributed environment, into storing into available data nodes in the cluster. Okay, so what is the reason? So for example, if any of the reason you have block 1, block 2, block 3. So block 1 replicated 3 copies, right? For some of the, if any of the reason, if this node goes down, this copy, the server goes down means this copy will lose the data. So but we have still 2 more copies are available, right? So that is the reason. So Hadoop is maintaining replication factor 3. 3 replication factor. It means so always data high availability. So there is no faulty tolerance. So in any chances, we will not lose any data. That is the Hadoop architecture design. Okay, so mainly focusing on data. By the end of the day, client wants required their data safety and security. Right. So that's the reason Hadoop. If you are using Hadoop for analysis purpose, if you are using Hadoop, so they can maintain high availability type like so replication factor 3. So it means 3 copies of same data available. Even if some of the reason 2 copies goes, also another copy will still available. Okay, but here if you see, for example, you have one node down. Okay, so for example, just imagine you have one more data node is available. So you have one more data node is available. Okay, so you have data node is available. Now this node, one more, first node is some of the reason the first node is down. Some of the reason first node is down. So one copy goes down already. So block 1, block 2, one copy not available. Now what name node will do? So name node will wait for some of the time whether the whatever the server down will come back or not. So it will wait, it will check. So sometime it will check. The default time is 10 minutes 30 seconds. So if the default time 10 minutes 30 seconds crossed, but still the data node is down, some of the reason, maybe either network issue or any server issue, server down, operating system any issue. So if server is still off, so what name node will do? So name node will try to re-replicate the missing blocks. What is the missing block here? Block 1, block 2. This block 1, block 2 try to re-replicate into any other available data nodes. Block 1, block 2. You see, again still it is maintaining block 1, block 2, all 3 copies. So that is the Hadoop architecture design. So it will wait for some time. If any of the situation, if any of the reason, so if any data node goes down, so whatever available, the data available into that data node, after some time, automatically re-replication happened by name node. That is the name node duty here. Okay, so we have seen data storing. You have 100 GB file, if you store the data, it is loaded. But what is name node? What it will store? Actual data will be storing onto the data nodes, right? All the data nodes, data node 1, 2, 3, 4, 5, 6, 7. So whatever the data nodes available in your cluster, all the data nodes will store actual data, your 100 GB file. Okay, and also when you copy 100 GB file, when it's storing it, if it is storing into Hadoop, how much size? Each file 3 copies. So it means 100 into 3. So when you copy a file, 100 GB file, by storing into Hadoop, how much size? 100 into 3. So total 300 GB file will be stored into Hadoop. So it maintains 300 GB file into Hadoop. If you are storing 100 GB file, so it will maintain 300 GB because replication factor 3, right? 300 GB. So if one file goes also, one copy goes also, another two more copies available. If two more copies goes also, one copy is available still. But what will happen after 10 minutes 30 seconds? What will happen? So name node automatically re-replicate the missing copies, missing blocks copies, right? So it means there is no more data loss, there is no more faulty tolerance, right? So that is the Hadoop design here. Okay, so then let us go to the further. And so actual data will be storing on the data nodes. Then what about name node? So name node will store file system metadata. So what is meant by metadata? Okay, so let us see. You have 100 GB file. What is the file name? For example, sample.txt, right? So that file name, file permissions, file size, file owner, and time of timestamp, what time you stored. So all the information we will call it as metadata. The metadata will be storing into the name node memory. So what it will store here? Metadata will be storing. Metadata will be storing into name node memory. Okay, so what is metadata consist of? Metadata consists of, let me take a paint again. So what is metadata? Metadata consists of file name, file owner, file permissions, right? Then timestamp, then how many blocks divided, how many blocks file has been divided, block names, block locations, in which data node the blocks are stored. Then what is the other one? Permissions, file owner, timestamp, block names, block locations, block divided, how many blocks divided, block names, block locations, some more are there, so that we can see. So these are the information called as metadata. So where it will store, this information will be storing on name node. Okay, so this is called as metadata information. This metadata information will be storing on name node. So it will be storing into the name node. Metadata, we'll call it as metadata. This information will store into metadata. Okay, name node in the form of metadata. So that metadata will call it as, like, there are two steps are metadata available, two components. One is fs image and edits. When we are going one by one slowly, so we can discuss what is fs image and what is edits and all. Okay, so this complete information related to the file properties. So these are called file properties, file permissions, file properties, everything. Okay, so these are the file system metadata will be storing on name node memory, right? So let us go to the ppt. So we have seen, right, when you copy a file, the file will be split into blocks and storing into directories. So this is called Hadoop distributed file system. Okay, so what is distributed file system? So when a dataset or file is grows the storage capacity of a single physical machine disk, so it becomes necessary partitions it across a number of separate machines and disks. So file system that manage the storage across a network of machines and disks are called distributed file system. So it means when you copy, where you have a single machine, for example, you have a single machine, so you have 100 GB file. So when you try to copy single machine from single machine to outside other machine, it is taking a lot of time, because so one machine, even you have resources also less resources, right? So it will take a lot of time. Similarly, if you have a cluster means group of computers connected in a network called cluster or a distributed environment. So multiple machines connected in an environment called distributed system. Okay, so if you are trying to copy a file outside from outside to distributed environment, so it will utilize all the resources available in the machine in the distributed system, and copying or reading or writing both are very fast compared to single machine processing. So that's the reason, so where we are using file system that manage the storage across a network of machines. Disks are called distributed file system. Okay, so reading writing is very fast compared to normal. Okay, so in Hadoop, large files will be partitioned into small pieces called blocks and stored across a network of machines. That is, we have seen here. Where is the diagram? So here, if you copy a big file, the file will be split into small pieces, blocks, and each block is copied into available data nodes in the Hadoop cluster, three copies. Each block is replicated into three copies. For example, you see block 1. How many copies? Black one, black one, black one. So three copies. For example, if it's a block 100 GB file you copied, so totally by the end of the after you copied the file, how much size? 300 GB data, right? 300 GB data available. So that's a like faulty tolerance. So it means you will never lose data. That is Hadoop design. Okay. Then let us see. So Hadoop components. Hadoop, there are two types of components are available in Hadoop. One is HDFS and MapReduce. So what is HDFS? HDFS is a distributed file system with faulty tolerance and high throughput for applications. It means it is always available for to access the applications of the data. Data is always available to access of the applications by end users. And also I can say it as this is storing the data, storage layer. So where it will store the data? Into the data nodes, right? So we have data nodes available in the cluster. So in the cluster, data will be storing into data nodes, right? And another component is MapReduce. What is MapReduce? It is a programming model with key and value pairs. So programming layer. Okay, so I can say it as processing layer. So Hadoop is a combination of two components, storage layer, processing layer. So let me take a paint and then, so Hadoop. So this is your Hadoop environment, right? Then I can say storage layer plus processing layer. Storage layer, processing layer. Okay, so what and all storage layer consists of? Storage layer consists of, so we have three more components. Name node, data nodes, so multiple data nodes we have, right, in the cluster. So name node, data node, and secondary name node. And when it go to the Hadoop versions, we have standby name node as well. Right? Standby name nodes, other some of the nodes available. Well, let us see one by one. So we have main components, name node, data node, secondary name node, and standby name node as well. Okay. Then when it comes to the processing layer, what is it? Job tracker, task tracker, then resource manager. So this is starting from Hadoop 2x onwards, Hadoop 2x version onward. Resource manager, node manager. So job tracker, task tracker, Hadoop 1x, and resource manager, node manager, Hadoop 2x onwards. This is processing layer, storage layer plus processing layer. And also Hadoop is using for Hadoop is using for OLAP, online analytical process. So it means online analytical process. So this is not Hadoop is not suitable for OLTP. Hadoop is not suitable for OLTP, online transaction processing. It is not suitable. It is only suitable for OLAP, online analytical process. So it means to analyze the data. So if you have a data available already in outside Hadoop or whatever it is, so you have some data is available. So if you want to go for some analyze, where we can use it, Hadoop to analyze your data, analyze and get the report. Analyze means analysis of your data. So you have data. For example, if you are loading the data from outside to Hadoop, so it means where you are loading your data, here storage layer. From outside to storage layer you can load the data, and using some processing tools, some of the tools available in Hadoop, using these tools you can analyze this data. So that is called, I can say it as Hadoop main two components. What are the components in Hadoop? HDFS components of Hadoop. So one is HDFS, I can say as storage layer to MapReduce, processing layer, right? Storage layer plus processing layer. So this is Hadoop components, right? So these are the, one is storage layer, another one is processing layer. Storage layer and another one, I can say it as processing layer, right? So you can see this is important operations for Hadoop. Okay, Hadoop is using only for OLAP, online analytical process. Okay, so storage layer, processing layer. Storage layer comes under some of the like nodes. What is the nodes? Name node, data nodes, secondary name node, standby name node, which comes under storage layer. When it go to the processing layer, job tracker, task tracker in Hadoop 1x and Hadoop 2x onwards, resource manager, node manager. Okay. Okay. So this is Hadoop introduction moreover, and we'll go one by one, slide by slide. So what and all we have. Okay. So Hadoop components. Storage layer. It is a distributed file system with faulty tolerance and high throughput for applications. Right? Storage layer. And it is what it will do. Storage layer. It is used to store the data. Storage layer. What is means? Name itself. It is there. Storage. It means what it will storage means storing the data. What you want to store? Data store. That is called storage layer. And when it go to the MapReduce programming layer, programming model, programming layer. So it means if you want to process some data, so you can use some tools, which is the model of key and value pairs, using some tools. That is called programming layer or processing layer. Programming layer means so you have written some program, and for what reasons you have written the program? To process your data. That is the reason processing layer. I can say it as MapReduce is a processing layer. Okay, then let us go to components one by one, components of storage layer. And also Hadoop 1x architecture. So this is Hadoop architecture. We have already written here. So master node, slave nodes, name node, data node, anything. So name node or master node, we'll call it as this master slave architecture. Hadoop 1x master slave architecture. Hadoop 1x architecture. Hadoop 1x architecture, master slave. So one master, multiple slaves. These data nodes, we'll call it as slave nodes in the Hadoop cluster. So this is Hadoop 1x architecture, one master, multiple slaves. Okay, so we have one more node is available in Hadoop 1x architecture, that we will call it as secondary name node. Okay, and this is moreover, it is look like a backup of metadata. Other than that, nothing they will do. So secondary name node duty is to taking a backup of metadata on every 1 hour. There is a time slot interval is there, separate topic. When we are going for, we can discuss it. So name node, primary is a name node in Hadoop 1x environment. Secondary node is a, I can say it as backup node. So it means metadata will be backup on every hour as per default time zone. There is something checkpoint operation, we'll call it as, that is, so every 1 hour, so it will be checkpointing is happened and metadata will be automatically taken care of, backup will be taken care by secondary name node. That we can see later one by one. When we are coming to the metadata checkpoint operation, we'll discuss detailed on that. Okay, so this is Hadoop architecture, name node, one name node, multiple data nodes, and one secondary name node. And moreover, this is, I can say it as storage layer, right? So we are discussing about storage layer. Then when we are going for processing layer, we'll discuss one by one. Okay, so this is Hadoop architecture, name node, multiple data nodes, right? And data blocks will be, if you copy data will be divided into blocks, and each block is replicated copies like this way, data nodes, right? And what is name node will store metadata. What is metadata? Name of the file, replications, file owner, file permissions, and file blocks, how many divided blocks, everything we'll call it as metadata. Okay, so this is Hadoop architecture. And one more is secondary name node here in the down. Secondary name node is a backup node of storing the metadata. Okay, so let us see one by one. So name node, we'll discuss first component in storage layer, name node. What is name node? It is the master node of the master node in the Hadoop cluster, and it will store the file system metadata. What is name node? So name node is a master node in the Hadoop cluster, right? As per our diagram. What is Hadoop architecture? Master slave architecture. It will follow simple architecture, one master, multiple slaves. So master slave architecture. Okay, so, and it is the master node. It means name node is a main node in the Hadoop architecture. So it will store the file system metadata. What it will store? Will it store actual data? No, name node will not store actual data. Actual data will be storing in data nodes. But then what it will store in the name node? So file system metadata. Whatever you are going to store the files into Hadoop cluster, the file name, file properties, that and all we'll call it as metadata. The metadata will be storing into the name node memory. Okay, so it is responsible to store file system metadata. So name node duties are, so what is the metadata? So information about file owner, information about file permission, what are the permissions the file is having, and information about file timestamp, what time you copied the file. For example, if you copy a file, what time you copied the file, what are the permissions, and what are the owner of the file, and size of the file. It's important, right? File size, replication. If you copy a file from outside to Hadoop, it will be divided into replication as per the Hadoop architecture. It will be divided into blocks, right? That is, we'll call it as blocks. And replication, how many copies each block is replicated, 2 or 3 or 4 or 5 something. By default 3, as per Hadoop, by default 3. If you want, you can reduce the replication, or if you want, you can increase the replication. So similarly, replication and name, if it is divided into multiple blocks, what are the block names? And if it is divided into blocks and each block is stored into different data nodes, what are the locations? Location means which data node those blocks are stored, right? And block size, everything will be storing into the metadata name node. That where it is stored in the, that is metadata, called as metadata. And where it is stored in the metadata, name node memory, right? And that is the name node duty. And also, first point of contact for all HDFS operations is the name node. What does it mean? Let me go you. If you see, if you copy a file 100 GB, right? So it is storing actual data into these data nodes. But where the file name metadata storing here, right? So when another user, you copied a file. So another user trying to read the same file, or else after you copy, you are only reading the same file, trying to read the same file, sample.txt, right? So when you want to read the file, how we can read it? You cannot go to directly data nodes, right? You cannot directly go to data nodes. What is the reason? So you don't know. The data nodes are storing actual data. Data means what is inside the file, what is the data is having. But if you want to read the file, you need a file name, right? So that is what you need to contact name node. If you want to read the file, you need to contact name node. So if you are trying to read sample.txt file, so you need to contact name node, and name node can check whether name node metadata, the sample.txt file is available or not. So if it is available, then respond. What it will respond? Respond to client. So where the data node are, where the sample.txt file data is available, in which data nodes, how many blocks it is divided, where the blocks are available, nearest blocks information, they'll send it to client. Then again after that, client can able to connect directly with the, for example, if there's data node, they can able to connect here directly and they can retrieve the data. So first point contact is name node. Otherwise, they cannot find out where the data is available, right? So that is name node part in Hadoop storage layer. Okay, so it means it is storing into the metadata, and it is the first point of contact for all HDFS operations, all Hadoop operations, any of the Hadoop operations if you are trying to perform. So name node is the first point of contact. Okay, that is name node history. Then we'll go to the data node. So what is data node? Data nodes are slave nodes in Hadoop cluster. So data nodes are slave nodes, right? So master slave architecture, Hadoop architecture, it will follow master slave. Then what are the data node? It is a slave node. So multiple data nodes available in Hadoop cluster. It is called as slave node, right? Slave node. And what it will store? Data nodes. Data nodes will store actual data. So when user is trying to copy some data from outside to Hadoop, where it will store, the actual data will be storing into Hadoop named data nodes, right? In the form of, how it will be storing? In the form of blocks. It means before storing the data, it will be split into blocks, right? Split into blocks, and each block is stored on the respective available data nodes inside the cluster. Slave node in Hadoop cluster, and data node is a slave node in the Hadoop cluster and responsible to store the actual data in the form of blocks. Okay, and each block replica on a data node is represented by 2 files in the local native file system. So normally each block is replicated 3 copies, right, into separate data nodes. Apart from that, if you take it one copy of block, okay, so in that local means native file system, Linux file system, okay, so in the Linux file system, each block is represented again 2 files. So one is like this, you can find it. For example, this is one of the block. So if you copy a file, the file is, this is the one block. So actual file is like block size, and this block metadata of the second file. So in the native file system, it is storing representing like block. The block is representing on this type of here in the local file system in that respective data node. Okay, and the first file contains data, the first file, this file, and second file contains this block metadata, not file metadata, not actual file metadata. The second file contains this block metadata. Okay, and the second file contains blocks metadata including checksum. Checksum means timestamp for the data and the generation of timestamp, including checksum for the data and the generation of timestamp. Checksum means whether the latest data or old data. So based on that time, if any modification or if any deletion, addition is happened in the data level, complete file level. So that is called as checksum, and as well as generation of the timestamp. We'll call it as this blocks metadata. Okay, that is data node will store it. These are the data node. So it is a slave node, and it will represent 2 copies of 2 files in the local native file system. Okay, then what is HDFS distributed file system? So HDFS is a file system written in Java. So based on the Google file system. So before developing HDFS file system, they have used Google file system, GFS, Google file system. Based on that, they introduced HDFS file system. Okay, and also it sits on top of native file system. What is native file system here? Linux file system. Okay, so native file system such as ext3, ext5, those are the file system types available in Linux, ext3 or ext4. And also it provides redundant storage for massive amount of data. What does it means? So if you are using a cluster, if you have a cluster, and cluster means more than one data nodes or more than one machine connected in a network called cluster. So if you take a 10 node cluster, so one name node, one secondary name node, remaining 8 data nodes, for example. So 8 data nodes means how much size? We have a lot of space. So it means massive amount of data available, data nodes to store the data. That is using industry standards. So at the load time, when you are loading the data is distributed across all the nodes. It means when you are storing the data, when you are copying the data from outside to Hadoop, it is not copying into one data node. So it is copying into multiple data nodes, or else available data nodes. It means or else all the data nodes available into the cluster. All the means not all. Whatever the configuration done, so based on the data nodes, it will distributed all the data nodes. It is not a 1 or 2 data nodes. It will distribute all the data nodes available in the cluster. So it means it is distributed. It will distribute across all the nodes. Okay, and it provides for efficient processing. So when you want to read write the data, that is fast accessing, fast processing. That is the reason where Hadoop is using for distributed file system. We can call it as distributed file system. Okay, then let us go to the next slide. So, and also when you go to here, if you see, this is Linux machine and how it will be disk storage native file system. Let me explain. So if I'll take it a paint, so for example, this is blue box is your Linux machine, your Linux machine. Okay, so your Linux machine, this is, and then each and every machine, physical machine, so we need a operating system, right? So we need a operating system. So to store the operating system, if you want to install the operating system, what we required, we need a disk. Disk means hard disk. So this is disk. For example, this is disk storage. Disk means what is a disk? I can say it as hard disk. Hard disk for storage. Okay, OS, operating system storage. So this is, I'll make it a separate color, hard disk storage, right? Okay, so then after the hard disk storage, we have a on top of hard disk. So you are going to install some of the operating system. What is that operating system? So for example, if you are installing on top of hard disk, so if you are installing some of the operating system, so you are going to install Linux operating system, any of the Linux flavor. So we have Linux flavor, Linux OPE operating system. So you are going to install Linux operating system. That operating system, we will call it as native file system. Native file system. What is native file system? ext3 or ext4. ext3 or ext4 are operating system types. After you install your Linux operating system, there is a file system will be created. That is called ext3 or ext4 file system. Based on your operating system, there is a file system will be automatically created into on top of Linux. Okay, so that is called your Linux operating system. So let me take a separate color. Okay, then on top of operating system, we'll create, so normally we will install Hadoop in general. So this is called Hadoop installation. Hadoop or HDFS. I can say simply Hadoop or HDFS. Like this way, where we can install Hadoop. Okay, so this is what. If you see Linux machine, the blue box is complete Linux machine. Okay, and inside the Linux machine, physical machine, you need a disk, hard disk for storage. And inside the hard disk, you have to install one operating system, either Windows or Linux. So we are going to install Linux here. And on top of when you install Linux, there is a file system will be created automatically. That is ext3 or ext4 file system types. So on top of Linux file system, generally we will install Hadoop. Okay, so that is Hadoop installation history. This is here like, so disk storage, native file system. On top of native file system, we'll install Hadoop. Okay, that is Hadoop, where we can install and how it is installed. Installation we can see separately. Okay, some of the key points available. What are the key points? Let us see. Okay, so key points are, so we have seen here, we have seen cluster, right? So how to, when you copy a data, it will be storing data into, splitting into blocks, and each block is replicated through 3 copies, right? But what is the block size? We have not discussed. That block size we have to discuss now. So what is the block size and what is the default block size? How many Hadoop versions? The block size will be decided based on Hadoop version you are using. Okay, so let me take a fresh one. So let me draw a picture again. Name node, secondary name node, data nodes, data nodes, data nodes, right? So data nodes connected with name node, all the data nodes connected with name nodes, right? So let me write it. Name node, secondary name node, right? What it will have in name node, metadata will be storing. Okay, then when it goes to the data node 1, data node 2, data node 3, data node 4. Okay, so for example, if you have a file called 100 GB, sample file 100 GB space, 100 GB size. So when you copy a file into Hadoop, how it will be, we discussed already. So how it will be, the file is split into blocks, small pieces called blocks. Block 1, block 2, block 3, just imagine block 4. Okay, 4 blocks. Block 1 I can say it as B1, B2, B3, B4. Total 4 blocks. For example, just imagine 4 blocks, and each block is copied into okay. So now if I'll take a block 1 color, okay, so then let me take the names. Block 1, block 2, block 3, block 2, block 4, block 3, block 1, block 2, block 3. So total how many? 3 block 3 is 3 copies. Block 4, we need to make it here again, block 4. Then block 2. Then what is the other one? Block 1. Block 1, block 1, block 1. Okay, so like this, each block is replicated 3 copies. Okay, now let me take the colors. Block 1, block 1. Okay, this is block 1, and let me take block 2 for green color, block 2, block 2, block 2. So this is extra, we'll change it. Okay, then let me take another block 3. What is the block 3? Some blue color. So block 3, block 3, block 3. Okay, then this is block 4. Okay, so let me change it. Okay, let me take a block 4 color first, then violet color. This is block 4, block 4, block 4. Okay, so this is block 4, this is block 2. What is a block 2 color? Green. Block 2. This is block 4. Okay, so block 4, block 4, block 4. So everything is 3 copies, right? You see now. So this is the name is wrong. Block 4. This is okay. So like this way, the blocks will be split and storing across 3 replications into available data nodes. But what is the size of the block, each block? That we have to see now. Okay. So let us see what is the block size. So block size will be divided based on the Hadoop version we are using. Okay. What is it means? So if you are using Hadoop 1x, we have Hadoop 1x, Hadoop 2x, Hadoop 3x as of now. Okay, so let us will see what is. So Hadoop 1x, if you are using Hadoop 1x, default block size is 64 MB. And if you are using Hadoop 2x, 128 MB default block size. Similarly, if you are using Hadoop 2x, 3x, 256 MB block size will be divided automatically. So the block size, how it will be divided? Based on your Hadoop version. Okay, so block size will be divided based on your Hadoop version using. So it means, for example, the same file, if you are using Hadoop 1x, Hadoop version Hadoop 1x, so the block size will be 64 MB each block, and it copies. And if you are using Hadoop 2x, so 128 MB the block size, block 1 size 128 MB, block 2 128 MB. Like this, it will be divided into blocks. For example, if you are using, let me take a calculator. You see, so if you are using 100 GB Hadoop 1x, so how many blocks it will be divided? What is the file size? 100 GB. By how much your block size? 64 MB. Then count. So 100 into 1024 by 64. So 16 blocks it will be divided around. So 1 GB, 100 GB means what is the file size? Okay, let me take it. For example, if your file is 100 MB, okay, 100 MB by 64 MB block size. So one and a half block. It means first block is 64 MB, remaining block is 34 MB. Block size will be divided, right? 100 MB. If you have a file, similarly, if you have 256 MB file, 256 MB file by 64 MB block size, 4 blocks will be divided. It will divide it into 4 blocks. Okay. Similarly, if you have 512 MB file, 512 MB by 64 MB block size, how many? 8 blocks it will be divided. Right? Similarly, 512 MB, if you have 1 GB file, so what is 1 GB? 1 GB file means 1024 MB. 1024 MB, right? 1024 MB by 64 MB. So 16 blocks. 1 GB file will be divided into 16 blocks if you are using Hadoop 1x. So similarly, what about 100 into 100? 1600 blocks. If you are storing 100 GB file, so how many blocks it will be divided? 1600 blocks will be divided if you are using Hadoop 1x. If your block size is 64 MB. Similarly, if you are using Hadoop 2x, so you have 512 GB file, 512 MB file by 120 MB block size. So how many blocks it will divided? 4 point. 512 MB, 512 MB by 128 MB block size, 4 blocks, right? Similarly, you have 1 GB file, 1024 by 128 MB, 8 blocks, right? So 1 GB 8 blocks for your normal if you are using Hadoop 2x. So 1 GB 8 blocks, then into 100, 800 blocks. If you are copying 100 GB file, okay, and if you are using Hadoop 2x environment, 800 blocks will be created, right? Similarly, if you are using 256 MB by 2, 400 blocks will be created. Let us check. So your file size is 1024. It means 1 GB. Okay, 1 GB file. So if you are downloading, if you are storing, what is your block size? Hadoop 3x 256 MB, right? How many? 1 GB, 4 blocks will be created. Then what about 100 GB? 100 into 4. 400 blocks. If you copy this 100 GB file, if you are using Hadoop 3x, 400 blocks will be created. So that is the Hadoop blocks size will be decided based on your Hadoop version. Okay, so let us continue. I'll stop it here. Let us continue for the next session.